Imagine a discovery so profound it could unravel everything we thought we knew about the universe. Not a subtle tweak to our models, but a seismic shift that challenges the very laws of physics as we understand them. The James Webb Space Telescope, humanity's most powerful eye into the cosmos, has uncovered something so strange, so unexpected, that even a Nobel Prize-winning physicist has sounded the alarm. The universe is behaving in ways we can't explain. This isn't hyperbole. It's a wake-up call from the stars, a signal that our understanding of reality might be fundamentally flawed. What the telescope has found isn't just a new galaxy or a distant star, it's evidence that the universe might be operating under rules we've never imagined, rules that could rewrite the story of existence itself. We're not talking about incremental updates to textbooks. We're standing at the edge of a cosmic precipice, peering into a realm where time, space, and even the nature of reality might be far stranger than we ever dared to dream. Buckle up, because what follows is a journey into the unknown, where science meets mystery, and the universe dares us to rethink everything. Let's start with the telescope's latest revelation, a discovery that's sending ripples through the scientific community. Deep in the cosmos, some 12 billion light-years away, the telescope has spotted a cluster of galaxies that shouldn't exist. These aren't the chaotic embryonic structures we'd expect from the early universe. They're massive, intricate, and eerily stable, with stars and gas flows that suggest a level of maturity far beyond their supposed age. According to our current models, the universe at this stage, barely a billion years after the Big Bang, should be a turbulent mess, a cosmic soup of raw materials still coalescing into crude forms. Galaxies this old should be small, disorganized, and struggling to hold themselves together. But they're giants, with complex structures and star formation rates that rival modern galaxies like our own Milky Way. The data is clear, precise, and utterly baffling. The telescope's infrared gaze, combined with ground-based observatories, has confirmed that these galaxies are not anomalies but part of a larger pattern. Something is fundamentally off, and it's forcing us to question the timeline of cosmic evolution itself. Why does this matter? Because our entire understanding of the universe hinges on a delicate framework, a story we've pieced together from decades of observations and mathematical precision. The Big Bang, the rapid expansion of space, the slow formation of stars and galaxies, these are the pillars of modern cosmology. But if galaxies were already this advanced so early in the universe's history, those pillars start to crumble. The standard model tells us that it takes billions of years for gravity to sculpt gas clouds into the elegant spirals and massive clusters we see today. Yet here we are, staring at cosmic titans that seem to have skipped the awkward adolescent phase entirely. It's as if the universe hit fast forward, building structures with a precision and speed that defy every simulation we've ever run. This isn't just a glitch in the data, it's a challenge to the very laws of physics. Could there be forces at play we haven't yet discovered? Could the universe have a hidden mechanism, a kind of cosmic accelerator that we've completely overlooked? The telescope's findings are a stark reminder that the cosmos doesn't owe us easy answers. Now let's dive deeper into the strangeness. These galaxies aren't just too big or too complex, they're also pumping out stars at a rate that's almost incomprehensible. In the early universe, star formation was supposed to be a slow, laborious process, limited by the availability of raw materials and the chaotic conditions of a young cosmos. But these galaxies are factories, churning out stars with an efficiency that rivals the most productive regions of the modern universe. The telescope's instruments, peering through layers of cosmic dust, reveal gas flows so smooth, so organized, that they suggest a level of stability we thought impossible at such an early stage. This isn't just a matter of tweaking our models. It's a sign that something fundamental is missing from our understanding. Some researchers are beginning to speculate about exotic physics, perhaps undiscovered particles or fields that catalyzed galaxy formation in ways we can't yet grasp. Others are revisiting the role of dark matter, wondering if its influence was far more dynamic than we ever imagined. Whatever the answer, one thing is clear. The universe is playing by rules we haven't yet learned. This brings us to the Nobel Laureate's warning, a voice of caution and curiosity that carries the weight of decades of groundbreaking work. The physicist's concern isn't rooted in fear, but in a profound recognition of the unknown. The universe, they argue, might not just be bigger or older than we thought, it might be fundamentally different. One emerging theory suggests that the early universe wasn't a uniform sea of chaos, but a patchwork of wildly different conditions. Imagine pockets of space where time itself flowed differently, where physical constants like gravity or the speed of light weren't as fixed as we assume. This isn't science fiction. It's a hypothesis grounded in the strange behavior of the cosmos we're now observing. The telescope's data hints that some regions of the early universe might have been governed by laws we don't yet understand, creating islands of accelerated evolution amidst a sea of cosmic infancy. If true, this could mean that our measurements of the universe's age, based on the redshift of distant light, are skewed, not because our instruments are wrong, but because the universe itself is more complex than our rulers and clocks can capture. Let's pause for a moment to let that sink in. The universe might not be a single uniform system marching to the beat of one cosmic drum. Instead, it could be a tapestry of diverse realities, each with its own rhythm, its own rules. This idea challenges the very foundation of cosmology, which assumes that the laws of physics are the same everywhere, at all times. But what if they aren't? What if the constants we rely on, gravity, electromagnetism, the strong and weak nuclear forces, aren't truly constant? Some physicists are now exploring the possibility that these constants evolved, shifting in subtle but profound ways as the universe expanded. The telescope's discoveries lend weight to this idea, showing us structures that seem to have formed under conditions we can't replicate in our models. It's a humbling thought. We've built our understanding of the cosmos on the assumption that we know its basic rules, but the universe might be playing a far more intricate game. Now let's push the boundaries even further. What if the strangeness we're seeing isn't just about physics, but about the very nature of reality? One bold hypothesis, championed by some of the most visionary minds in science, suggests that consciousness itself might play a role in shaping the cosmos. This isn't mysticism, it's a scientific proposition rooted in quantum mechanics, where the act of observation can alter the state of a system. In the subatomic world, particles don't have definite properties until they're measured. What if this principle extends to the cosmic scale? Could the universe, in some strange way, be responsive to the presence of observers? The idea sounds wild, but it's not without precedent. Quantum experiments have shown that reality is far less concrete than we once thought. with particles existing in multiple states until observed. If consciousness influences reality at the smallest scales, could it also leave its mark on the largest? The telescope's findings, galaxies that seem to defy the expected timeline, might be a clue that the universe is more interactive, more dynamic than our classical models allow. This brings us to another mind-bending possibility. What if the universe isn't just a single linear story, but a series of cycles, each with its own beginning and end? Some theorists propose that the cosmos doesn't start with a single Big Bang and expand forever. It breathes, collapsing and reborn in an eternal rhythm. In this view, the galaxies we're seeing might not belong to our universe's infancy, but could be remnants of a previous cycle, etched into the fabric of space-time like cosmic fossils. This cyclic cosmology suggests that the universe reinvents itself, with each cycle governed by slightly different laws. The telescope's discoveries, structures that seem too advanced for their time, could be echoes of an earlier epoch, a universe that evolved faster or differently than ours. It's a radical idea, but it resonates with the strangeness we're observing. The cosmos might not be a straight line, but a spiral, looping through seasons of creation and destruction, each one leaving traces for the next. Let's zoom out and consider what this means for us. The universe, as revealed by the telescope, isn't just a collection of stars and galaxies. It's a puzzle, a mystery that challenges our deepest assumptions. Every new image, every data point, is a reminder that we're not just observing the cosmos, but participating in it. Our tools, our minds, our curiosity, they're all part of the same cosmic dance. The strangeness we're uncovering isn't a threat, it's an invitation. It's the universe daring us to ask bigger questions, to imagine wilder possibilities. What if space-time isn't a fixed stage, but a fluid medium, bending and shifting in response to forces we can't yet measure? What if the laws of physics are less like stone tablets and more like a living language, evolving with the cosmos itself? These aren't just abstract ideas. They're the kind of questions that have driven every major breakthrough in science, from the discovery of gravity to the unraveling of quantum mechanics. Now let's ground ourselves in the science we do know. The telescope's observations are built on decades of technological triumphs, from the precision of its mirrors to the sensitivity of its infrared detectors. These instruments allow us to peer back in time, to a universe so young it was still glowing from the heat of its birth. But even our best tools have limits. The redshift of distant galaxies, which we use to measure the universe's expansion, assumes that light travels through a stable, predictable medium. But what if that medium, space-time itself, isn't as stable as we thought? Some researchers are now exploring whether the anomalies we're seeing could be due to variations in the fabric of space, ripples, or distortions that skew our measurements. Others suggest that dark energy, the mysterious force driving the universe's accelerating expansion, might not be uniform, but clumped, creating pockets of accelerated growth. These ideas are speculative, but they're grounded in the data we're collecting, data that refuses to fit neatly into our existing frameworks. This brings us to another layer of the mystery, the role of dark matter. We've known for decades that dark matter, an invisible substance that outweighs normal matter, plays a crucial role in galaxy formation. It's the gravitational glue that holds galaxies together, shaping their growth over billions of years. But the telescope's discoveries suggest that dark matter might be doing more than we thought. Could it have properties we haven't yet detected, perhaps interacting with normal matter in ways that accelerate star formation. Some models propose that dark matter isn't a single uniform substance, but a complex family of particles, each with its own effects on the cosmos. If true, this could explain why some galaxies seem to have formed so quickly, their growth turbocharged by a type of dark matter we've yet to identify. The telescope's data is pushing us to rethink not just the visible universe, but the invisible scaffolding that holds it together. Let's take a step back and reflect on the human side of this discovery. Science isn't just about equations and telescopes, it's about wonder, about the thrill of chasing the unknown. When we look at these ancient galaxies, we're not just seeing light from billions of years ago. We're seeing a challenge to our imagination. The universe is telling us that it's bigger, stranger, and more complex than we ever imagined. It's a reminder that every time we think we've cracked the cosmic code, the universe throws us a curveball. A century ago, we thought the Milky Way was the entire universe. Then we discovered galaxies, and the cosmos expanded beyond our wildest dreams. Now, we're facing a similar moment, a chance to redefine not just the universe, but our place in it. Are we passive observers, or are we somehow woven into the fabric of reality itself? The telescope's findings suggest that the answer might be more profound than we ever expected. This brings us to the philosophical heart of the matter. If the universe is stranger than we thought, what does that mean for us? Are we just specks of dust in a cosmic storm, or are we something more? The idea that consciousness might play a role in shaping reality isn't just a scientific hypothesis, it's a call to rethink who we are. If the universe responds to observation, if it evolves in cycles or varies across space, then our role as observers, as thinkers, becomes central. We're not just studying the cosmos, we're part of its story. Every question we ask, every discovery we make, is a step toward understanding not just the universe, but ourselves. The telescope's images are more than data, they're a mirror, reflecting our curiosity, our ingenuity, and our relentless drive to know more. Let's explore one final possibility, one that pushes the boundaries of science and imagination. What if the universe isn't just a physical system, but a kind of cosmic intelligence? Not in a religious sense, but in a deeply scientific one. A system so complex, so interconnected, that it behaves with a kind of purpose. Picture the universe as a vast network, constantly adapting, evolving, and learning. The galaxies we're seeing, with their impossible complexity, might be the universe experimenting with new forms, new structures, new ways of being. This idea, speculative as it is, resonates with the strangeness we're observing. It suggests that the cosmos isn't just a machine, but a process, one that we're only beginning to understand. The telescope's discoveries are a glimpse into that process, a hint that the universe is more alive, more dynamic than we ever imagined. So where do we go from here? The telescope's findings are just the beginning. Every new image, every new spectrum is a piece of the puzzle, a clue to the true nature of the cosmos. Scientists are already planning follow-up observations, combining the telescope's data with other observatories to map these strange galaxies in even greater detail. New theories are emerging, from exotic particles to variable physical constants to cyclic cosmologies. Each one is a thread in a tapestry that's still being woven. The universe is challenging us to think bigger, to question deeper, to imagine wilder. It's a call to humility, to awe, and to courage. The courage to admit that we don't have all the answers, but the determination to keep searching. As we stand on this cosmic threshold, let's embrace the mystery. The universe isn't just a collection of stars and galaxies, it's a story, one that we're writing together. The telescope's discoveries are a reminder that science isn't about certainty, it's about exploration. It's about daring to ask questions that don't have easy answers, about chasing truths that might change everything. What do you see when you look into the cosmos? Just light from distant stars, or a living, breathing mystery that's inviting you to join the dance? Let your mind wander, because the universe isn't just something we study, it's something we're part of. Let's explore it, not just with telescopes, but with wonder, with imagination, and with the courage to face the unknown.